cameras roll by, we'll be talking about the chatliers principle.
Alright, here on this side we have reactants A and B, which are at equilibrium with the products C plus D. If you add more of the A, B decreases and the products C and D increase, which makes the products favored in this equation. Here in this equation, like before, on this side we have reactants and this side we have products. On this side, if we add more C to the products, D decreases and A and B increase, which makes it shift to the left towards the reactants, and the reactants are favored in this equation. In this equation, the reactants are A plus B plus heat, and the products are C plus D plus E. The reactants already has heat, which you can see, and if you add more heat on top of that, it shifts to the products, which don't have any heat, and the products are favored in this reaction.
Today, we have two of my associates, Zach and Tony, demonstrating to you the reactants and the products at equilibrium, showing that the reaction rate of the products, the reactants, and the products run back and forth each other at equal rates. And this is when the chemical equation is at equilibrium.
On this side, we have A plus B plus heat, which is the reactants, at equilibrium with C plus D plus E, which is the products. And the products are losing heat, which makes everything shift to the left, and the reactants are favored in this equation. Alright, in this equation we're talking about pressure, and we have N2 gas plus 3H2 gas is at equilibrium with 2 NH3 gas, and the products have 2 molecules of gas and the reactants have 4 molecules of gas. And if you increase pressure, the products are favored because the products have less molecules, like as you can see in this diagram. They have less molecules and they can fit more than the reactants that have more molecules and that you can't fit anymore that's in there. Right, in this example we have Zn, which is in the solid state, plus HCl, which is in the aqueous state, is at equilibrium with ZnCl at aqueous state, plus H2 gas, plus heat. Now what would happen if we increase the concentration of HCl? If we increase concentration of HCl, it'll shift to the products because you'll add more of this and it'll have to shift to the right in favor of the products. What happens if we increase in temperature? If we increase in temperature, it'll shift to the reactants because there's heat on this side already to begin with, so it'll shift this way.
Alright, that concludes today's lesson in Chatliers principle. Tune in next week when we'll be talking about acids and bases and the origins of Mr. Abdul's beard and how it grows so fast. Do you not like the way your teacher's teaching you?
Mr. Abdul, I don't know what you're saying.
That's sad. So sad. If you want to learn some real chemistry, be sure to call this number right here, right now, and be taught by Prestige Chemistry Worldwide.
Display a new sound. We are live on stage. Dazzling, dilated display a new sound. Check it out, you're now rocking with the best. Dazzling, dilated display a new sound. We are live on stage. We do it for you. We do it for you. We do it for you. We do it display a new sound. Basic mathematics, addition, subtraction. Me and the mic, we got this animal attraction. Mid-city out to Manhattan, ain't nothing fancy. Yellow cabs pass me by, I call Delancey. Keep my team moving through lights, cameras, and action. Thoughts to ideas, designs to manufacturing. And still Travolta, I'm still Samuel Jackson. Blasted, live on stage is where it happens. Step to the zone, spotlight on, the sights on, all eyes on. Turn the tables and the mics on.